the first example we're going to talk through in 5.2 is actually going to be an example that does not relate to conjugates. So you know how I just said 99%? This is the 1% of problems that we're going to do that doesn't relate to conjugates. All right. So this is still section 5.2. It's a continuation from what we did yesterday. So this is an example of a question that looks something like this. Oops, I don't want to do that. Oops. That's fine. So now when we look at something like this is a tricky question for two reasons. Number one, there is a lot of exponential stuff going on in the top. So number one, that is happening, which makes it kind of a bummer. And number two, there are two different bases. All right. Now, most of the time that these questions work out, remember how yesterday we had talked about if the bases are different, you can't add the exponents, you just have to leave it alone, you can't do anything else with it. If the two bases are different, you're just done. You can't do anything else. This is an example of one of those things where the bases are technically different, but we might be able to rewrite. So you remember how yesterday we did the radical thing where I was adding two radicals together and I just said you can't add two radicals together if they're different. And then we said, well, maybe we could rewrite one of them and make them the same, and then we could actually add them together. That's the same thing that's happening here. So in these types of questions, and mostly, I think there's one of these on the big ideas thing tonight, but mostly this is an SAT style question because they're going to give you an answer for this that's very, very common to what most people would have, which what they would have is they would do 36 and 36, combine these together, combine the exponents, and then they would divide 36 by 6 and give you whatever that answer is. That's what their common answer would end up looking like. But in this case, we have to do something different, okay? Now, I'm just going to ask you a yes or no question. Is it fair for me to say that 36 is the same thing as 6 squared? Yes. This is a true statement, right? So now, effectively, what I'm going to do is I'm going to change this problem to have every single base be 6. So instead of writing the number 36, I'm going to write 36 as 6 squared. So I'm not going to change the problem at all. I'm not changing anything about this problem. I'm just rewriting it in a different way. And now you've noticed that we have changed this problem to now have all problems with the same exact base. So we've used the same base with every single one of these, and now it's turned into something where I should be able to see that I can use all of the properties of radicals and exponents and whatever we need to combine my bases and be done. All right. So as I look at this, I'm going to now simplify. I have a power raised to a power. Now this is another thing, another little step. This is like 7th grade math. A lot of people are going to want to tell me that this is the same thing as 10/12. That 2 times 5 6 is the same thing as 10/12. It is not. Please don't do that, because that is not the true statement. That's not right. When you multiply two fractions, you multiply straight across the top and straight across the bottom. My first fraction, 2, is really 2 over 1, and then my second fraction is 5 over 6, which makes this 10 over 6. So please do not multiply top and bottom, because that's one of the most common things that I see in these problems. They're just big issues. Because really, if you multiply both the top and the bottom by 2, you're not changing the fraction, right? 10/12 is equivalent to 5 6, so you're not actually changing it. So what I'm going to do is multiply straight across the top and then straight across the bottom. So my first one will turn into 6 to the 10/6 times 6 to the 6/8 over 6 to the 4th. And now we're just going to go through and simplify as much as possible. So I know that if I have two bases that are multiplying, what can I do with the exponents? I can add them, right? So I can add my two exponents, which my two exponents are 10/6 and 6/8. And now can I add them right now? Can I just say this is 16/14? Nope. Guess what? That's another common thing that people do. What do I have to do before I can do that? I have to have a common denominator. What's the nicest common denominator? 24. 24 is, right? So I can multiply this one by 4 over 4, and I can multiply this one by 3 over 3. So this is going to end up turning into 40 over 24 plus 18 over 24, which is the same thing as 58 over 24. So this whole thing right here and here has simplified down to this. So now my new equation is going to be, or my new expression is going to be 6 to the 58 over 24 all over 6 to the 4. We're still not done. And I picked one that was pretty ugly because it was going to bring a lot of kind of old tricks back into play. So hopefully we're hitting every single one of the examples in one go. Everybody good so far? Yeah.
So can you walk through how, like, you turn 5, 6, like, squared into 10, 6?
Yeah, so remember this, when you have a power to a power, you multiply, right?
Yeah.
So power to a power means multiply, so 2 times 5 sixths. And 2 is the same thing as 2 over 1, and now to multiply, you go straight across the top and straight across the bottom again. No results.
When you were talking about that, I was thinking of something else, and I got really lost.
Yeah, that's good. I'd rather you ask it than not know. All right, so now we have a new expression right here. This is my new expression. This is not my final answer yet, because now what we need to do is we need to combine this into one, because we should see that we can, right? We have a base on the top and a base on the bottom that are the same, so they will be able to be combined. So what do I do when I'm dividing two bases that are the same? What happens to the exponents? I subtract them. So this is the same exact thing as saying 6 raised to the 58 over 24 power minus 4. Right? And now I'm just going to go through and I'm going to do the math for the fraction. So I know that I have 58 over 24 minus 4 over 1. Again, I have to have common denominators. So if I have common denominators, this means the same thing. I'm going to multiply this one by 24 over 24. So this is going to be 58 over 24 minus 96 over 24, which is equal to 38, 38? Yeah, 38 over 24. So now this is saying that my new expression up top is going to be equivalent to 6 raised to the negative 38 over 24 power. And when you simplify expressions, when you simplify things with exponents in them, you really don't want to have negative exponents. And if you don't want to have negative exponents, what happens with an exponent when it's negative? What do you do to get rid of it? Remember? We flip it like the reciprocal. If it's up top, move it down low. So this is going to end up turning into 1 over 6 to the 38 over 24 power. And right now, as far as we know, up to this point, right at this moment, that is our final answer, because we don't know how to simplify that more yet. Yeah. Yeah.
But in general, 5.1 and 5.2, you don't simplify the n fraction. You wouldn't, go 19 over 12.
Here you could, if you wanted to. Yeah, you totally could at this point. So I didn't really think about that, but yes, you could. This worked out to be really nasty because I just made up the problem, but you absolutely could rewrite this one as 19 over 12. Okay. The only time and the reason that Michael's asking this question is he's saying, do I want to simplify this every time in 5.1 and 5.2? And do you remember in 5.1 when I said don't simplify the fraction because you want to be able to put it underneath another radical? And when you're thinking about that, I said that when we had multiple terms that were going to be going underneath the radical. Right now, we only have one thing that would be going under a radical, so I don't really care about anything being moved under the radical together. There's only one thing. If there's a radical, there's only going to be one thing underneath that radical. Right? Now, what was just brought up, where Michael said, can I simplify that? Because he's thinking about the radical. That's why this answer is an issue. This answer is going to end up being an issue because we have a radical in the denominator technically, right? That over 12 thing, this thing right here is a root. So this means that I have 1 over the 12th root of 6 to the 19th power inside of a radical. Radicals are no good in denominators. And I'm going to give you kind of the brief explanation as to why, or kind of let you think about it. If you imagine a cake, it is possible to cut a cake into like 5 pieces, right? Or it is possible to cut a cake into 10 pieces. It's actually possible to cut a cake into like 4.5 pieces, right? So you could actually cut a cake into those. It's kind of hard to wrap it around. But you could cut your cake into a certain amount of pieces, right? So you could do that. You cannot cut your cake into an irrational amount of pieces because you never know when to stop your number. If the number never ever stops, you never know when to actually stop cutting. You don't know what you're doing. You don't know how to make the pieces equal. So since you don't know how to cut those pieces equally with an irrational number, which is what 99% of radicals end up being, you can't do that in the denominator of a fraction. So you can't have radicals that are, or denominators and fractions that are radicals. So our job right now is going to be to get rid of them, okay? So this is actually the extent of that type of question that we talked about yesterday, but now it turns into a conjugate question, okay? So up until this point, I don't think that should have been something that was, you know, crazy hard. I think that changing the 36 into 6 squared was probably the only thing that made it like, wow, I don't know that I could have done that on my own. But everything else, I think you should have been able to fight your way through. All right. So now let's start talking about conjugates because this is where the issue starts. I'm going to come back to this problem in a little while. If I forget to come back to it, remind me because I probably will. So what conjugates mean, basically, for this section alone, conjugates mean that you are not allowed to have radicals in the denominator of a fraction. So if you're not allowed to have radicals in the denominator of a fraction, there's 3 cases of something that could happen. We could have something, and I'm just going to use 1 on the top for right now. It could be anything on top, but right now I'm just going to keep it easy. We could have 1 over a plus a square root of a number. We could have 1 over a minus the square root of a number, or we could have 1 over just the square root of a number by itself. And when I say that, I mean any root. I mean, you can do that with any type of root. But what you're going to do is you're going to multiply by the conjugate. Now, the conjugate is basically, and actually I should take this one away. This one right here. I'm going to take these m's away because you're not going to see any problems like this. It is possible for those to pop up, but you're not going to see any problems in that case. This one you will. You will see this one, so that one having an mth root is fine. Those 2 there, you're not going to see them. So now what you're going to do is you're going to multiply by the conjugate. The conjugate is just this exact same thing, but you flip the sign on it. So what I'm going to do is multiply by the conjugate. And the conjugate of that thing is just multiplying the same exact thing, but getting rid of the sign, or changing the sign in the middle. So a minus the square root of b. And you have to do that on both the top and the bottom, because if you only do it on the bottom, then you have instantly taken away the integrity of the problem. If you just multiply one thing on the bottom, that problem instantly becomes different than it was before. So that problem is now different. All right. So this one, we would multiply by a plus the square root of b. And then this one, we would just multiply by, I don't know how I want to write that. Let's do this and we'll come back to that. Because this is, if this is all just dealing with square roots, let's keep it straight and then we'll come back to it later. This one you would multiply by the square root of b. And you're going to see why I erased that in this assignment. Okay, so pretty easy stuff to recognize. Pretty easy stuff to kind of fix, but it introduces a lot of algebra. So it's a pretty easy recognition. Like you could look at something and say, oh, I see 1 over 5 plus the square root of 7. So if I see 5 plus the square root of 7, I'm going to do 5 minus the square root of 7, and I'm going to be all good. That being said, it just introduces a lot of algebra that you're going to have to use. So if I see something like this, and I ask you to simplify a problem that looks like this, where it's 1 over 5 plus the square root of 3. So 1 over 5 plus the square root of 3. We instantly see right now, there really isn't an issue with the 5, but there's an issue with the square root of 3. Because there's a radical in the bottom. So since there's a radical in the bottom, I can't use that. So in order to get rid of it, I have to multiply by the conjugate. So I'm just going to take exactly what I see here. Now, important disclaimer, it does not matter if there's a radical here if there's a radical here, if there's a radical here and here, it doesn't matter. You multiply by the conjugate every time, it'll take care of the radical. So I'm going to multiply by 5 minus the square root of 3. And there are a very select few of you in here who might know why I'm doing it. If you remember way back to chapter 4 when we learned about factoring, do you remember when we learned about something called the difference of squares? And the difference of squares was something plus something, something minus something, and then the term in the middle canceled. That's what we're having done here. We're getting the term in the middle to cancel. So multiplying straight across the top is super easy. 1 times 5 minus the square root of 3 is 5 minus the square root of 3. In the denominator, we're actually going to multiply out 5 plus the square root of 3 and 5 minus the square root of 3. And now this is double distribution. So I'm going to go through and multiply 5 times 5, which is 25. 5 times the negative square root of 3, which is minus 5 square root of 3. 5 plus the square root of 3. And then the square root of 3 times the negative square root of 3, which hopefully we realize is just negative 3. And that was all underneath 5 minus the square root. Right? Good on double distribution on that? Now, the whole reason that we do that is because these are going to be opposite. So those things right there are going to cancel with each other. Oops, this shouldn't say plus right there. Just be 5/5. So those two things right there are going to cancel with each other. They're going to go away. In the future, when you do conjugates, you only need to multiply this one times this one. So this one times this one, and this one times this one. You don't need to do all of the formulaing in this because they're difference of squares problem. They actually will cancel every time. That's the point. Because now if you look at it, this turns into 5 minus the square root of 3 all over 25 minus 3, which is 20. I know that's fun. I know that's exciting. I know that's everything that everyone has ever dreamed of. It's the best thing about math. No question. Love it. Any questions on that? Any issues or concerns with that? Yeah.
So the only like, so of course it's okay with the negative numerator, but the only time we would flip it is if there was a negative exponent. Like how they're like how in so I'm talking about the old like the problem we did before 6, the negative 38 over 24.
Yeah.
The only instance we have to put that in that case.
Yes. Only when you have a negative exponent. Yeah. Okay. Now, what I want to think about here is if we have something that's like this, 2 over the square root of 2. This is that one that I was talking about where it was like 1 over the square root of 2. Here, these problems are really, really nice because you don't have to do any FOILing or anything. You just multiply by the conjugate, and that conjugate is just going to be that. Right? That's all it's going to end up being. So the conjugate is just the same exact thing. So now this would end up with 2 square roots of 2 over 2. It would be nice, wouldn't it? Yeah. Yeah, and you should. Thank you. So when you do this, you should actually simplify because this is all multiplication. And I can take 2 over 2, and I know that 2 over 2 is the same thing as 1. So this would actually just simplify down to the square root. Okay. Now, if you remember way back to when I said 1 over the nth root of b, if you remember way back to when you said that, this is going to create issues. This is going to create tough things because if I have something like 1 over the 4th root of 6, if I have something that looks like this, this is going to create an issue because what a lot of people are going to end up wanting to do is they're going to want to multiply by the 4th root of 6, right? Because that's what you would know how to do. But if you think about this, that would create, and don't write this down unless you want to write down like a wrong example, but this would create the 4th root of 36. And the whole point is to get rid of radicals in the denominator, right? Is the fourth root of 36 a perfectly nice number? It is not 9, for those of you thinking that it's 9. 1 over the fourth root of 36 is still no good. We haven't solved it yet. So the easiest way for me to explain or to go through these types of problems is instead of doing this, because this won't work, it will work eventually, but it's going to be significantly more work. What you need to think of this as is instead of saying 1 over the fourth root of 6, I could say 1 over 6 to the 1/4 power. Right? Does that make sense? We're just changing it back to the radical form or the exponent form from the radical. So now if I look at that, what I want is I want this number in the bottom to be the whole number, right? And if I want it to be a whole number, I have to have 6 to a whole number power, right? And if I have 6 to a whole number power, it's going to become 6, right? 6 to the first power is 6. How do I make 1/4 become 6? Or I'm sorry, how do I make 1/4 become 1? What do I add to 1/4 to make it 1? Not quite. You're thinking multiplying, I'm thinking add. I add 3/4, right? So if I multiply this by 6 to the 3/4 power, I now know here, when I multiply bases that are the same, you add the exponent, right? So this is saying the exact same thing as 6 times 6 to the 3/4 over 6 to the 4/4. And 6 to the 4/4 is just 1, right? 6 to the 4/4 is just 1. Oh, hang on. I don't know why I did this. This should stay a 1. Yeah, I don't know why my problem changed. I was a little confused there for a second. I was going with the original problem, sorry. Did I? Just wrote a 6? So are we all good with how we went from 1/4 plus 3/4 equals 4/4, and now this thing is the same thing as saying 1, so now I'm left with 6 to the 3/4 over 6 to the first power, and 6 to the first power is just 6. Now, huge learning point right now. Please do not cancel the 6's here. They are not the same. You cannot say 6 to the 3/4 over 6 will cancel. You cannot do that. It will not work. So you can't just cancel these, because if you cancel them, what happens to that 3/4? No. This number is not 6. This number stands for the fourth root of 6 to the third power over 6. I can't cancel anything that I see here. This is really the same thing as the fourth root of 216 over the 6th power. You can't cancel anything there. The only thing that you might be able to do, and in this case you can't, would be to try to pull out perfect fourths out of that 216. That's the only thing that you could try to do, but you can't. So since you can't do that, don't do that. All right? So that being said, do not cancel anything that you see here. Any of these answers are actually acceptable. If you leave me this one, or this one, those are all the exact same. They're all okay. I don't really have an issue with any. Okay? Yeah.
So I just like had a thought. So 3/4 of 6 is like 0.756, so like 4.5 times 6 would be the same thing. Okay? 4.5 is like 75%.
Not necessarily, because you're thinking of this as multiplication, not as an exponent. Because 6 times 3/4 would be 4.5. But 6 raised to the 3/4 is not.
That's what I'm trying to say. 6 raised to 3/4 is like 4.5.
Is it actually?
Well, I just did like 0.75 times 6, and then I got 4.5.
So what is 6 to that power? 6 to the 3/4 power. Okay, so yeah, so you can't do anything with the point there, like multiplication. It won't work with any multiplication.
Because I was just thinking because it seems like it would be 3/4 of just a normal. Oh wait,
No, because that's multiplication. Exponents is how many times you would multiply it. So it's basically saying you would multiply 6 by itself 3/4 of the time, and that doesn't really make sense. The very last problem that I want to run through, and this is one that you could potentially see, is a problem that looks like this, where we actually have more things in the radical, but it does the exact same thing. So like the 8th root of n to the 18th power e to the 7th all over n squared e to the -1. So if we have something that looks like this, basically what I'm saying is, yesterday we learned that if we have a radical, we could break that radical into two different pieces, where we could say the radical at the top and the radical on the bottom. You can do that. Now that being said, breaking it down to the radical on the top and the radical on the bottom might not be the best case scenario, because I think it was Alec yesterday that said, if it's all under the radical, can we do this first and simplify this first? That is absolutely what I would do. I would simplify this as much as possible, as fast as possible, before we actually start to break things down, because a lot of you are going to look at this and say, well, if I break it to the top and the bottom, now I've got a radical in the denominator, and that's no good. But what I want to do is I want to look at this as this thing first and simplify that first, and then try to simplify it later. So I have the 8th root of n to the 18th over n squared. 18 minus 2, right? 18 minus 2 is 16, so I get n to the 16th power. 7 minus -1, because it's division, right? So 7 minus -1 is 8, so now I have p to the 8th power. Is there any issues so far with anything that you see in the denominator of the question? There's no denominator here at all, right? So since there's no denominator, there's no issue with conjugates, but we do still have to simplify this, because this is saying the same thing as n to the 16 over 8. And then p to the 8 over 8, which simplifies down to n squared times p. For the most part, yes. Well, this one's done, yeah. But there are a few other things that could potentially happen. I'm trying to find one. I think we're good, actually. Oh yeah, we can. Yep. So this one right here. So this one. Yeah. So this one is an issue. Now the question is, and this might be something that you guys have to do a couple times on the big ideas question. You might have to see in the denominator that there's an issue. So what you have to do is you have to get rid of that issue. Now that being said, right now there is an issue with what is in the denominator of this answer, because there's a radical in the denominator. That 12 is a radical. So I've got 1 over 6 to the 19 over 12. Now in this case, I want that number in the denominator, that exponent in the denominator, to be a whole number. What is the next closest number to 19 that will be divisible by 12? Only think of adding. Don't think of subtracting, because that makes things tough. 24 would be the next closest number that is perfectly divisible by 12, right? How do we get 19 to become 24? What do you add to it? 5. So I'm going to multiply by 6 to the 5 twelfths. So I'm going to do that on both the top, and I'm going to do that on the bottom. And this will turn this into 6 to the 5 twelfths over 6 to the 24 twelfths, which is the same exact thing. You can write it any way you want. I don't really care. If you want to do it the 12th root of 6 to the 5th power all over 6 squared. Yes, I know that does not look simpler. I get it. I understand. I don't know who decided that that would be the most simplified version. I don't know who decided that you needed to know how to cut a piece of cake into 6 squared pieces or 36 pieces, and they didn't want you to be able to cut it into the 6 to the 19 12 pieces. I don't know why. Just that. Yeah.
When you're set there to
The 6 to the 19 12s? Not anymore. Not that we've learned the conjugates, not anymore. If you would have stopped me from teaching conjugates, I would have accepted it, but you didn't. It's too bummer. You can't. Yeah.
So, would you want us to keep it expensive and answer, like, would you just accept 6 to the 5 to the 12?
Yeah, over 6 squared. Yeah. Yep.
And 6 squared will always remain 6 squared.
You could write it as 36.
You will, okay, good.
In all honesty, if you write it in any form of, if you write, this isn't a radical. 6 squared is 36, right? So if you want to write it as 6 to the 5 over 12 over 36, there's no issue with 36 pieces of cake, right?
Yeah. That just works to be like.
Yeah. You good?
No, but,
Correct. When it's not perfect, right? Yes. When the denominator or when the exponent in the denominator is perfect, when it's a whole number, you don't do anything with it. When the denominator's exponent is a fraction, that's when you have to fix it. All right.
wait, so on the six, it is the 58.4 part of this problem, I think it was.
Yeah.
Why can't you just put the 6 and just have that? Like that part, the black circle part.
This thing right here, because we have two things that are, so like this number right here up top is more than 6. This number is more than 6, so I can start to cancel some certain numbers of 6s. So like in this case, you see how like 58/24 is a big number?
Yeah.
I could actually start to simplify. There are, and I should say, there's more than one way to solve this problem. I wanted a different route so that I could use the conjugate form. There is a way that you could have solved this without using the conjugate, yes. Yes.
Alright.
But I wanted the route that we had to use the conjugate so we could come back.